Today we are going to see the last chapter of this unit, and that is electrophoresis. So in this electrophoresis, we are going to learn about introduction of electrophoresis, factor affecting electrophoretic mobility, technique of paper, gel, capillary electrophoresis, and its application. So let us start with the principle of electrophoresis, right? So before we go into the principle, let us get to the introduction of electrophoresis. So what happened in electrophoresis? There are many cations and anions are generally used in the preparation of medicaments, or they are generally used, like for an example salines and all. You have a cations and anions, basically like sodium and potassium. So how do you differentiate that, right? If you have, or the when you want to separate the proteins and amino acids, DNA, RNA, so there should be a method to separate the charge particle. So thus the separation of the charge particle is done through the method called electrophoresis. So what is here, if we look into the introduction part of electrophoresis, is a differential rate of migration of ion molecule in electrolyte solution under the influence of electric field in a support medium. The support medium could be paper, it could be a gel, or it could be a starch. So depending on that, we have even segregated, or we have classified the electrophoresis. So look into the picture, you could see it here. There is an electric field applied, and then electrostatic force and frictional force and electrophoretic retardation force. So what is basically, these are the factor which governs the migration of charged particles. So in the next slide we can see that how does the separation happen of the charged particle under the influence of electric field. So this is a figure, motion of charged particle by electrophoresis, a useful method for separation of substance based on their charge to mass ratio. So look into the principle. So what does the principle says? The principle of electrophoresis states that the charged or a molecule migrates when placed in electric field. The rate of migration depend on its net charge, size, shape, and applied electric current. So the velocity of an ion is directly proportional to electric field and electrophoretic mobility. What is electrophoretic mobility? Is a distance migrated in a certain span of time by the ions. The electrophoretic mobility is given by the equation q 6 pi neta r. So this is what I mean. This, if you look into this, the n is a viscosity which plays a vital role, and those all other parameters is a constant. 6 pi r is a constant, q is a charge, and q is a electrophoretic mobility. So when you look into this, what happened electrophoretic mobility of a substance generally when is controlled by the retardation. So let us see that what are the factor which is affecting and what are the driving force of migration. The result of electrophoretic force of attraction between the electric field and the charge molecule, and the retarding force due to the friction and electrostatic repulsion from the molecule of transport medium. So what are the factor which governs or which affects the electrophoretic mobility? So the rate of migration of charge molecule depends upon the following factor: the strength of electric field, which is directly proportional to the more the electric field you apply, faster could be the migration of charge particle. Size and shape. The size, the smaller the size, the migration is more, and the shape, obviously the oval shape or the has a more separation or travel faster. So relative hydrophobicity of a molecule, the tendency to form its I mean the ionization around it, the ionic strength and the temperature of the buffer, molecular size of the taken biomolecules, net charge density of the taken biomolecule, shape of the taken biomolecule. So these are the factor which affects the electrophoretic mobility and the migration of ions. So let us see about the other factor. That what could be. So types of electrophoresis, that the electrophoresis has been classified in two different categories. One is frontal electrophoresis, other is zone electrophoresis. Under the classification of frontal electrophoresis, you have micro electrophoresis and moving boundary electrophoresis. And then under the zone electrophoresis, you have paper electrophoresis, cellulose acetate, electrophoresis, gel electrophoresis, and capillary electrophoresis, which is there under your syllabus. All modern electrophoretic apparatus have supporting medium these days. A supporting medium is a physical support through which the charge molecule gets separated. It has two primary functions: absorption and molecular sieving of the taken molecule, which are intended to be separated. Depending upon the presence or absence of supporting media, the electrophoresis can be classified in free zone or zone electrophoresis. For the next detail of this electrophoresis, we will be seeing into the other slide or other video. Before I go into this, I will give you a glimpse of the factor affecting the suppression of the charge molecule is basically depend upon the net charge, shape, and size. So if we look into the lithium, potassium, and sodium, right? The molecular weight is, so what you see it here, the ionic mobility could be greater for, if you look into the hydrogen, lithium, and sodium, if you look that sodium comes to be first, slower than the H plus, it's because it has hydrated radii is greater. So you have to take a consideration of hydrated radii of the molecule. So size is hydrated. The smaller the size means the lithium and the sodium. Lithium, sodium, and potassium. You see that the chronological order of the separation is not is the first is a hydrogen, and then lithium, and then sodium and potassium. So the other factor which governs is the temperature, and then it is controlled by the shape, and then the charges carrying on it, and then the current supplied. So these are the factor. So the rest part of this we will continue in the coming video, and that we will talk about the different type of electrophoresis and the different supporting medium. Till